Good evening, friends. Before we start today's session of industrial flow meting techniques, I will just tell you very brief about that what we have studied till now. We have studied till now why we study flow meters. Then we have studied different kind of applications. Then we dive down in a different hydraulics properties, which is very important to understand the different principles of magnetic flow meters, where we see the continuity equation, where we see the laminar or turbulence flow. We have seen how the parabola is important and what is the meaning of downstream and upstream, and we have seen 5 major principles. Based on the 5 major principles, there are 36 flow meters we have seen. Then we have seen the first flow meter, DP type, differential pressure. In the differential pressure, we have seen the orifice flow meter, and in orifice flow meter, we understand V is proportional to root delta P rho. So what is the meaning of delta P? We have seen is a P1 tapping, P2 tapping, and then we are taking this delta P to one of flow computer. We are mixing now steam or the gases. Then we have to do NTP and STP things, so therefore the density compensation. So this is not only a delta P flow meter, the delta P transmitter, we also have one pressure transmitter and the temperature transmitter for doing this density compensation. Why? Because steam and gas are the compressible fluid. Today we will see our 4.2. If you see our table, the 4.2 is our electromagnetic flow meter. In the same way, like we seen our orifice plate delta P flow meter, similar we will see here. First we will see that the gray things looks like a orifice. Now how this electromagnetic flow meter looks like, we are seeing here. Now if you observe the different kind of picture you are seeing here. If you see, here is the only junction box, no display. Here again you are seeing there is no display, only a junction box. Here you are seeing display as well as the sensor part. These are the only sensor parts. So what is the meaning of electromagnetic flow meter? We will understand. Here you are seeing sensor different, display different. Here you are seeing different type of display. Here you are seeing display sitting on the sensor. Here you are seeing display sitting on the sensor. Again you are seeing here different type of configuration here, different kind of configuration here, and different kind of configuration here you are seeing. So one by one we will discuss these all very important things. First of all, we will try to understand if someone tell what is the electromagnetic flow meter. So if you see this and you tell it is a flow meter, it's wrong. If you see this and you say it's an electromagnetic flow meter, it is wrong. Then what is right? Right is, if I am telling EMF, electromagnetic flow meter, it means your this part, okay? This is, I will say, sensor part, okay? Sensor part or head, 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 plus your converter, electronics, converter or electronics or display. Means next time electromagnetic flow meter means your sensor or head or tube plus your electronics or your display or your converter. Understand? Now this is what type? It is the flange type. There are two sides, is a flange. Okay. Here no flange. So this is called a sandwich type and this is called the flange type. Okay. In this kind of head, the converter will be here, like here. So two wires will come and it will be connected here. So this is called the remote version. Similar thing is here. And here it is sitting here. It is sitting here. It is sitting here. So it is the not remote, it is the integral type. Integral type and remote type. Depending on the application, you have to select this kinds of configuration of electromagnetic flow meters. Means if it is inside the chamber, if chamber can be full of the water, this is the location is remote, then you have to choose like this. But inside the plant, pump house and all, pipelines are above the ground, then you can choose this kind of the integral type. So what we understand: integral type, remote type, then flange type, sandwich type. So whenever you are selecting any flow meter for your application, you must know these small things. Okay. Now we will go to the next slide and we'll understand more. So first we understand the working principle of electromagnetic flow meter. So my question to you, do you know what law governs electromagnetic flow meter? Yes, you are right. Because it is the electromagnetic flow meters, so Faraday's law governs it. What is the Faraday's law? We all know Faraday's law, how it developed, how he shown to the world when he tried to measure the flow of Thames River in England. Okay, Faraday's law from very beginning, very small classes also we keep on studying this kind of law. So I need not to tell you this law again and again, but I will tell you at this juncture what is important to you. So what this law says: E is proportional to B, it is proportional to V, it is proportional to L. Now what is B, what is V, what is L, that we will discuss. And what is E? Okay, E means what? E means EMF. Okay, B means what? That is the magnetic field. V means what? It is the velocity of fluid. What is L? L, when we understand the construction of a electrometer, we will understand is the two electrodes. So this L is the distance between two electrodes. In the coming slides, we will see it. Then how it will be equal? For making it equal, we need one constant. So we can see this equation over here. Okay. So what we are doing? We are, with this formula, we are calculating V. So V equal to E upon constant BL. Now we got a V. Then we know what we know. Q is equal to area into velocity. Area we again know. So we can calculate the V, and from V we are calculating the Q. This is the principle of electromagnetic flow meter. Now we will see more about the construction. Then our some doubts if arise will be